Welcome to SpaceX. Here we are in the lobby. It's very white right now, but there are actually some cool elements coming in soon that will make it less white. In the front of the building we have our engineering offices and space for about 300 people per floor, and we've got a total of about 3 floors that we can open. Right now only the first floor is occupied. We try to aim for something which is a very open plan to maximize communication and make it sort of fairly nice looking. This place used to be quite dismal. That's my office over there, actually. We really try to minimize the number of offices that we have because doors limit communication. Everyone at the company, with the exception of a few people in like HR and finance, actually are in cubes, including vice presidents over there. There's Gwen at her cube.
I should have cleaned up financial coming. Although this is really reality, I guess. I'm responsible for sales. I'm in charge of making sure that there's revenue here in the company, and we're working on lots of Falcon 1 deals, Falcon 9 deals, and Dragon deals.
So this is just a little area where people can meet and have sort of an impromptu meeting. Obviously also very open. I think it's actually quite helpful to have this openness because then you can sort of see what people are working on their computers. Like what Matt McKeown here is doing. What are you working on there?
I'm making a assembly documentation for the Draco.
Okay.
RCS engine.
David is driving the development of our in-space thruster, which is called Draco, there's a little piece of it. Well, actually, that's just a sample spun cone.
Yeah, we're doing all our testing at our facility down there. We got a new vacuum system, so kind of going back and forth between there and trying to progress along.
Right. So the Draco engine is what is used in our Dragon spacecraft and also in the upper stage of Falcon 9 for orbital maneuvering and re-entry. This is our meeting room, VIP meeting room for when we meet with our customers, and if the CEO of a customer comes through or something like that. It's kind of cool because it's got this glass that goes opaque, and we put a motion sensor on it, so as you walk in, the glass goes opaque. We named our conference rooms after the great rocket engineers and great scientists related to space. So we think they really deserve the credit for enabling us to become a spacefaring civilization. So we're fairly science and engineering centric. We have some conference rooms named after astronauts too, but we try to focus more on the people that actually designed and built the rocket. That's where we have our server room, which has, I don't know, somewhere in the order of 500 processors for computing, doing computational fluid dynamics, finite element analysis, and obviously all of our server storage for our 3D solid modeling and that kind of thing. It's amazing how many processes you can get in a small space these days with modern computing. Over there, this is under construction, but this is where our mission control and launch control will be. So there's imagine like 2 big cinema screens. That's one of them, and that's another one over there in the back. And we can either have one giant image, or we can have 4 smaller images. So this whole thing is going to get laid out, and there's going to be a glass tile floor which is illuminated from below, and these cool desks with kind of blue lights. It'll look really pretty neat. So this area is where we do all of our inspection. And it's climate controlled and particulate controlled, so because metals expand and contract at different temperatures, so we always want to make sure this room is at exactly 68 degrees for doing our precision measurement. And wherever possible, we try to design a part in 3D, to manufacture it in 3D, and then to inspect it in 3D. So we minimize the number of 2D to 3D conversions. Occasionally something's better in 2D, but mostly it's better in 3D. So here we are, and the temperature just went down a whole lot because we're in our precision control area. And what that machine is going to do is it's going to inspect that part down to within thousandths of an inch to verify that everything was machined as it should have been. So what we have here is, that's a mass simulator of the Falcon 1 first stage engine. That's a mass simulator of the second stage engine over there. and we have what's called a full hardware-in-the-loop simulation of the vehicle. So from an avionics and electronic standpoint and from a steering standpoint, the flight computer and avionics think that they're flying the vehicle to space, and then we verify that they've done all the computer's actually done all the things it's supposed to do to make the rocket get successfully to space. So here we're in our avionics test facility. That's where we do test avionics of all sizes and shapes. So here we have a bunch of thermal cycling chambers that'll take parts and put them through 50 thermal cycles to verify that things are going to be okay. And the temperature environment in space is much worse than on the ground because you don't have air to even out the temperature. So you could actually have something could be in searing sunlight or blackest night. And it's got to be able to handle much more of a temperature range than it would on Earth. That's a thermal vacuum cycler, so it'll test both. It'll test the out part in vacuum going through the temperature cycles. That's our shaker room. It's got two small and a big shaker, so we can simulate the enormous acoustic and vibrational loads that parts experience during the rocket takeoff. And that's really where things tend to break more than any other place.
Hey, how are you?
Good. We're just doing a little video blog thing of what's happening. Yes, exactly.
I'm Hawthorne. I'm an avionics engineer. What I'm doing here right now is to set up for a test upcoming of our second stage that we're going to send out to Texas for a hot fire. What you see here is our electrical ground support equipment, a copy of what we actually have out on Quadrant on the launch pad. We do exactly a one-to-one replica here to test out the stages before we send them out. So we will be putting the stage to its paces tomorrow, and we're just doing some preparatory work right now.
Yeah, this is our electromagnetic interference test chamber. It looks vaguely like a torture chamber, but it's basically set up so that when we can take our rocket or spacecraft and put the section here with all the antennas and radios, because there's like a dozen radios on the vehicle, or either transmitters or receivers of various kinds, and we're going to make sure they don't interfere with one another and that they've got good. We can sort of verify that the signal that's going out is going to be well received by the ground, and that's what we use this chamber for. It's really great. This area is used for the engine components, or the major engine components. So you can see there's a nozzle, or various nozzles at various stages of completion. And then you can also see the copper things are the chamber liners. You can see the difference between that's a Merlin vacuum configuration, which has got a more spread out nozzle section, and that's the sea level configuration, which has got a sort of short copper nozzle. Those are the propellant supply lines for Falcon 9. So they've got a single tank that manifolds out to 9 engines, and then you've got fill and drain lines. So there's a total of 10 sets of 5-inch diameter lines that manifold out to the various engines. So it's kind of like having like a 9-cylinder engine car or something like that. This is our tube bending area. So there's a lot of tubes on a rocket, and we have a couple of automated tube benders that once you program a particular type of tube, it could be a very complicated tube that looks like a crazy pretzel, and this machine can make that exact same tube every time perfectly. All right, so here we are in the SpaceX machine shop. We have about 30 different machines of all sizes and shapes. We have wire EDM machines, which is electric discharge machining. We've got lathes, mills. There's just an enormous amount of metal sculpting that takes place to create the vehicle. What a lot of people don't realize is that SpaceX makes about 80% of the vehicle by value in-house. So, for the engine, raw metal comes in and out comes an engine. And so it's on these machines that the metal is taken from its raw form and into the final machine part form. So a part like this will come in as a forging, and then it'll get turned and milled and cut, and eventually end up as an engine chamber liner. This is a new machine that just arrived. It's just being tested and put through its paces before we start machining on it. They were actually cutting the grooves on a chamber and drilling the holes that are necessary. for cooling. These are engine manifolds that connect the nozzle and the chamber. These are just various rocket parts for the stages, parts for the engines. Those are some sumps. That's a tube for the main oxygen supply line to Falcon 9. Some more nozzle parts here. Nozzle part. So that's our machine shop. Actually, I mean, I haven't gone through everything because there's a lot of detail here and some of it's proprietary, but it gives you a sense for what's capable. We've actually got a lot of off-site machining that we do as well. We have a very high engine production rate here at SpaceX. This year alone, SpaceX will make more rocket engines than the rest of U.S. production combined. And next year, we'll make more rocket engines than any country in the world. So that's a lot of rocket engines that all have to go through and be made very efficiently and made very accurately. And that's what all these machines are for. So what we're looking at here is a Merlin 1C fully regeneratively cooled engine. It's getting ready to ship out to our test site in Texas to be part of the 9-engine firing. This is actually the 9th and final engine to be shipped out for that. And when we do that firing, it's going to be quite spectacular. Falcon 9 is the most powerful single-core vehicle in the American fleet, and when Falcon 9 Heavy debuts in about 2 to 3 years, that will be the most powerful vehicle in the world because the shuttle will have retired by that point. So that's really quite significant. It's the raw equivalent of say an Airbus A380 or a 747. This thing is the turbo pump. This is the chamber, the nozzle. And then there's all the supporting structure in there with the avionics and control valves. And here you can see the difference with the Falcon 1 configuration. So it's a sealed pyramid. The stage valving is contained inside that pyramid. But other than that, it's substantially the same with the turbo pump and the chamber and nozzle. Very little difference really between the Falcon 1 configuration and the Falcon 9 configuration. So what we're looking at over there, that's a quarter section of the Falcon 9 17-foot diameter fairing. It's 17-foot diameter, obviously, and 50 feet long. It's capable of taking the largest satellites in the world, and it could actually literally fit a city bus in that fairing. It's that big, because that's just a quarter section of it. It's made of carbon fiber. It's very lightweight, and uses the most advanced analytical techniques to optimize the mass. So it's actually, I believe, the lightest weight fairing of its kind as well. What we're looking at here is the Dragon spacecraft pressure vessel. So it's almost done. We just need to do the forward and aft bulkheads. It's actually upside down right now, but you can see the main hatch, some of the windows. The actual common berthing mechanism where it berths to the space station is, well, right there, because it would ordinarily be the other way around. And this is an actual flight fidelity article that's going to go through full qualification testing. Right. This area is dedicated to our Dragon spacecraft assembly. So you see various tools. That's for our heat shield, making the composite parts in our heat shield. Over there are the side shields and the nose cone. That's the engineering test article. That's basically engineering pathfinder for our heat shield for Dragon, which is to use a very advanced material called the phenolic impregnated carbon ablator, which is really the best heat shield material you could possibly have. And this is our engineering test article of our Dragon spacecraft. So it's not flight fidelity. With the part we saw earlier, we saw the welded piece, that's actually flight fidelity. But this was used as an engineering pathfinder to figure out how we might make Dragon. And actually, it's been very useful. On the right there is a space station berthing mechanism ring. So that's an actual ring that will mate to the space station. There's another one on the Dragon itself, although the guide vanes aren't present. Here are various pieces like windows and pushers and frangible nuts, and these are structural bulkheads, structural reinforcing bulkheads. That's the little model we use to determine splashdown loading. So here we are in the east high bay. So we have two very large high bays. We're in the east one right now. The east high bay is used for Falcon 9 stage construction, and it's also temporarily used for storage, which is why you see various bits and pieces around, behind me. This area under the high bay is used for Falcon 9 tank fabrication. So you can see behind me various barrel sections for Falcon 9. That's actually serial number 2. That completed tank is serial number 2 of Falcon 9. Serial number 1 is on the test stand in Texas. And then serial number 3 is in barrel sections on the floor. And we're getting ready to weld together those barrel sections and create our third tank, which would actually be the first flight tank. So the first one was a run tank, second one is a qualification tank, and the third one will see flight. That's a Falcon 1 second stage bulge former. So that's a classic bulge forming tool that's used to take 2 welded cones of a typical refractory alloy metal like chromium hafnium alloy and bulging it to a round contour, which is the optimized contour for maximizing the efficiency of rocket thrust. This cleaner here is also climate controlled, particularly controlled, and it's currently used for propulsion components as well as temporarily it's used to do composite layout. So that giant tool you see there is the mandrel that's used to create the composite parts for Falcon 9. So it creates the interstage, the drag and trunk section, and the propulsion section skirt. Anything that's a body diameter, a 12-foot diameter cylindrical part. And that'll be moved over to the actual composites area when we have that composites preparation room done, which will be fairly soon. This area is where we do a lot of the Falcon 1 structural assembly. So behind me, that's a Falcon 1 half section of a nose cone. That's the tool on which the nose cones are made. That's an avionics, or rather a payload adapter cone. That's another payload adapter cone. That's a mandrel for the Falcon 1 interstage, which is similar to the Falcon 9 interstage. In fact, the Falcon 9 interstage is just a scaled-up version of the Falcon 1 interstage. This is a barrel section for Falcon 1 Flight 5. So we have Flight 3 on the island in the Kwajalein Atoll, ready for launch, almost ready for launch. Flight 4 is going to be right behind that. We'll launch in about 3 or 4 months' time. And then this is Flight 5, which will launch sometime in the first half of next year. We have a lot of customers that are interested in that, and we expect to do a deal on that fairly soon. And this area is also used for composites fabrication. So we've got a big oven there, which is used to put big parts in a small oven for smaller parts. What we're looking at here is a Falcon 1 upper stage. So you can see the engine and actuators and all that plumbing is for the attitude control system. It will actually hold the pressure bottles. There's a lot more stuff that goes in the back there, but you can see the tank and the little skirt at the back that holds a lot of the structure. That's for Flight 4, and then the Flight 5 unit is right there behind it with obviously not much stuff done on it yet. So this is a little snack section. So we offer people that work here get free snacks and drink, which is kind of a common thing in the internet world, but relatively unusual in the space world. And we think if people are working late and they need a snack or something, they should have one readily available. All right, well, thanks for following me on the tour. That was just SpaceX Hawthorne. There's actually a lot more other SpaceX facilities. We have a big test site in Texas. We've got a launch pad at Cape Canaveral, a launch island in the Kwajalein Atoll. And we're looking for great people of all kinds to join the company. So if you're interested, please send us a resume.
Five, 4, 3, 2, 1. We have liftoff.
Here we are on the coast of Florida at Cape Canaveral. This is where a tremendous amount of history has been made, obviously, in space. It's where Apollo launched from. The moon missions all came from Cape Canaveral. Over there we have the space shuttle and the Lockheed Atlas facility. There's the vehicle assembly building for the shuttle is over there, and then the Boeing Delta IV vehicle. The launch site we're using was formerly used by the Titan IV, which was the largest vehicle in the U.S. fleet. And we've done a lot of work to change and adjust it for our vehicle and make improvements. Let me introduce you to Brian Mosdell, who's managing the construction of the launch site here at Cape Canaveral, and will manage the ongoing launch operation here.
I have a lot of experience out here at the Cape launching rockets. I started here my career in the space industry in 1991, and I'm thrilled to be part of the SpaceX team.
Okay, so behind me is where Falcon 9 would sit during launch. And the big transformation that's going to occur over the next few months is the construction of the launch mount, and we're going to have the hangar constructed. Behind us, we see the giant lightning towers. There's a lot of lightning here at the Cape, and those things can pretty much protect us against Armageddon. Here we are on top of our giant ball of liquid oxygen. They say SpaceX has big balls, and it's true. It's capable of containing about 1 million pounds of liquid oxygen, more than enough for a Falcon 9 flight. Over there we have our flame duct. So you can see that big exit there is the flame duct. The rocket flames and a whole bunch of steam comes out of that hole right there. This wall is where they recorded the rockets that have launched here previously. The biggest rocket in the US fleet, the Titan IV, which is a really gigantic vehicle, used this launch site. It's a great heritage to be launching from the former Titan IV launch pad. And then we have our control room, which is 12 miles away, which is actually just outside the gates at Cape Canaveral, which makes it easier for visitors or customers to be there and look at their payload and be there in the control room with us without having to go through all the security of coming onto Cape Canaveral, which is actually an Air Force base. We first broke ground on our launch site about a year ago. And we expect to be ready to launch by the middle of next year. All right, so that mostly concludes the tour of our launch pad. We'll do another updated tour in a couple months, and you'll see how much this is transformed. It's going to be quite remarkable.